it's an interesting topic on social robot and AI. Okay, so normally when we talk about robots, so they talk about engineering, okay, and they talk about the robot arm for assembling cars, okay, in manufacturing and so on. But now in Industrial Revolution 4.0, we are talking about the robots and AI. And most interestingly is when you deal with human. Okay, so when we deal with human, then we can say as social robots. Okay, so I put some video on just introduction on my Instagram. These are what we do. All right. So what are things to discuss for today? Okay, I highlight 6 keywords, okay, or key important things to take away. First is on, do we need social robots actually? Okay, is it so important? Okay, is it relevant to us? Okay, so we'll discuss about it. Second is what a social robot can do. Okay, in this case, we limit to a robot called a Zembo, okay, by Asus. I think Post Patrick have a lot in Ontario. And then we'll talk about the user expectations versus AI. Okay, what are the expectations from the end user, okay, from the industry, from the public as well, and education side on healthcare. But how can it be solved by using AI? And then we'll talk about a little bit on what has been done with Zembo. Okay, a little bit on the experience because it's quite new and we've been working hard to explore everything that we can explore with Zembo. Okay, besides other robots, these are the new platforms that we can explore on. And some of I will discuss also on the number 5. Number 5 is on project examples. Some of the example on the application that we have developed. Okay, it's a simple one, not even to the industry, right? Just a concept. And then the plan on what I'm going to do next with Zembo. Okay, there's a lot of things that can be done, and hopefully you are part of it. Okay, you have the resources. Maybe you can try to develop new apps. Okay, for your projects. Okay, for your class projects and so on. All right. First, we go on. What is a social robot? Okay. So I guess everyone knows from the term itself, it's a robot that used for socialize. Okay, so a social robot is an autonomous robot that interacts and communicates with human or other autonomous physical agent by following social behaviors and rules attached to its role. Okay, so it's a high expectation for a robot. Okay, because normally in a simple or in manufacturing robot, they are focusing on the precision. They are focusing on how to perform the manufacturing part, assembly part, and so on. So they don't even care who are the user or human besides him, except on the safety part. But now in social robot, the expectation is quite high, okay, higher, where it has to be able to understand and communicate with social, okay, cues that people use. Autonomous robot that interacts and communicates with human or other autonomous figure by following social behaviors and rules attached to its role. Okay, following the definitions they have. So the question is, what robot is capable? Okay, what are the capabilities of robot for social behaviors? Okay, what are the abilities to respond and interact with human? Because humans, there are so many things to understand. Okay, there are so many uncertain things that robots should understand on the human. Okay, in terms of the language itself, in terms of the way you talk, the pronunciations, okay, the behavior, and so on. So it's quite high expectations on this one. So it's a huge task. That's why if you do on research, there's a lot of things to discover, a lot of things to explore. Okay. All right. And then we talk about a little bit on what is artificial intelligence. Okay, in definitions, it's a theory or developments of computer systems able to perform tasks normally requiring human intelligence, such as visual perceptions, speech recognitions, decision making, and translation between languages. Okay, this one is standard definitions. So basically, I get some figure. Okay, show some figure from the net to show overall picture of the AI itself. Okay, on the machine learning. Okay, which involve the predictive and analytics, deep learning, and then on the speech, where it covers text to speech, speech to text, and the vision used for image recognitions, as well as the machine vision itself. Okay, it can be for robotics, it can be for CCTV, it can be static cameras, and so on. And then we have the natural language processing, NLP, focusing on the classifications, focusing on translations, and as well as data extractions. Okay, then we have the expert systems. Then we have the planning and optimizations, also part of AI. And then the robotic itself. Okay, so basically, when we talk about social robots, it can cover most of this. Okay, might be not covering the expert system, not covering the planning and optimization, but on robotic, on visions, on speech, on NLP, and a little bit maybe on the machine learning. Okay, we can be embedded inside a different domain. Okay, I guess this is the standard figure. Okay, for those who just are new to AI, these are what are the domains or the fields that is being covered in AI. Okay, so of course we cannot cover everything. You have to choose which one that suits you. In this case, if you are talking about robotics, you have to select a few parts of AI, okay, to be one of your expertise. All right. You have a video here. Okay, so basically when we talk about AI, even in our lab, okay, so I show you a video.
Okay, but how? How to recognize patterns in chemistry, perform document analysis, iris biometric recognition, object recognition, robot interaction, analysis on chemical structure, and data-driven analysis. This is Machine Learning and Vision Lab, based in FTSM UKM. We focus on several research domains: document analysis, pattern recognition, biometric applications, autonomous robots, data-driven analytics, and chemoinformatics.
Okay, so this one actually part of it. So you can see the full video in our Facebook. Okay, but basically this is what are our focus in our lab, where one part of it is on the autonomous robot and vision systems. Okay, and it covers the service robots, intelligent robots, as well as social robot itself. Okay, hope you are good so far. Okay, if you am too fast, then you can ask me to slow down. Okay,
it's okay. It's
all
good.
Right. Now the next question will be: do we need social robots? Okay, on which purpose? Is it for childcare or elderly care, or is it for customer service? Okay, or is it for increasing productivity or added value, or is it for exhibitions? But we know that when we have social robots, it can create a lively environment. Okay, that one is something that we cannot avoid. Okay, we have to admit. Okay, these are some of the images. Okay, So we are thinking about the future, next 5 or 10 years, okay, where this thing there will be some robots, okay, might not be replacing the teachers, but it can act as assisted teaching assistants, okay. And then we already we already seen a lot of kiosks, okay, which is part of the robots, okay. And then we have this one is actually a picture of in exhibitions in museum as well as educational robots. Okay, here. So I I try to search some of the news on social robots. Okay, I found some. Maybe we can share to this class for today. Okay, so basically there are a lot of example of social robots, okay, the models, okay, besides Zembo that we are focusing on. Okay, we have one pepper robot. They don't have a leg, but they have tires, but they have a hand. Okay, then that makes the robot can do much better compared to Zembo. Okay, but the concept is the same, and the aim is also the same. Okay, social robots are bred for interactions. Okay, same for all social robots. They want to interact with humans. Okay, but how and how intelligent it can be, it depends on the developer itself. Okay, and the technology keep on growing. Okay, people testing on new data sets every day. Okay, so it's just a matter of time on how all this AI can be uh, integrated into one complete system. Okay, and then in Japan, they already start on deploying robots for eateries. Okay, for example, this one, a restaurant staffed entirely by Pepper robots, Pepper Palo Cafe. And then this one is basically on SoftBank, which also developed Now Robot and Wiz. Okay, they can do on table dancing duties, and also can clean the place until it's spotless. Okay, so how practical is it? How is it practical compared to humans? Okay, of course there are some limitations. Okay, because they rely on the batteries. Okay, and of course human can think much better and do much better, but they are trying to achieve what human can do. All right. So for this one, basically, I prepare some survey on uh, my Instagram. Okay, I just want to see some of the questions. Okay, so while listening, maybe you can take some time to answer some questions. Okay, it's just a simple survey. Okay, so you can go to my my stories. Okay, just to answer, we can discuss on the outcomes on these groups. Okay, response. All right. Meanwhile, let me proceed this one. So besides that, they are also trying on social care. Okay, this one is from the Internet of Business. So they're talking about robots to transform Japan's social care by 2020. Now it's 2021 already. Okay, so these are the robots. Okay, they try to make it autonomous. Okay, they try to interact with humans. Of course, there's a lot of things have to be considered here in terms of the safety, in terms of the load, in terms of the limitations, and so on. So I know we know Japan that is very advanced in testing all these things. Okay, they are very brave in testing and deploying new type of robots. And then another thing is social robot could replace human counselors. Okay, this one I take from technologies in I don't remember which paper is this. A study researcher from UK also shows that social robot achieve a fundamental objective of a motivational interview. Okay, so they start to become a counselor. Okay, how they did it is, of course, they are mimicking what the real counselor does. Next, in the conversations, robot carers, okay, could help lonely seniors. They are cheering humans up already. Okay, so they are talking about become a companion, okay, to the elderly. Okay, how? Okay, of course you have to. There's a lot of things. Okay, they have to discover what are the needs for the elderly. Okay, how they interact, what are the conversation, what are the activities, and so on. And then for business, robot waiters in Los Angeles time, okay, during the corona. Okay, so they are talking about replacing the waiters, okay, for serving purposes or dirty dishes collections as part of tryout of measures to respect social distancing and help curb the spread of coronavirus. Okay, at the family's Royal Palace restaurant in Netherlands. Okay, this one is also I found a lot in Instagram on the robots from Netherlands. It's quite interactive. Okay, compared to Japan. Okay, so Japan, I think they're not focusing on the look. Okay, but in Netherlands, they're focusing on the looks. Okay, they're putting some arts, some colors, and so on. Okay, but at the end, we are not looking at the appearance. We are looking at what are the capabilities. Next, we move on to service robots. Okay, which also interact with humans. For this one is in hotels and then also in restaurants. Okay, for serving, for asking for menus. Okay, for orders and so on. All right. So basically, all these things comes to one aims. Okay? How we want to utilize the use of social robots. Okay, there's a big questions there. Of course, when we talk about AI, it's artificial intelligence. You have to copy or mimic what human does. Okay, so it can only be achieved by copying conventional process by humans. The way, okay, the first one, how human treat children, for example. Okay, what are the two-way communications that normally being conducted by seniors or the moms or the parents with the children or the teachers with the children's? What are the communications involved? Okay, and it can be for entertainment or as a companion. Okay, so before they deploy or they develop the robot, they have to study on what are the conventional process. Okay, in terms of serving the customers, how human ask questions to customers. Okay, what are the questions? Okay, the act of robot service in public spaces. Okay, in libraries. Okay, or is it in train stations and so on. And then how to provide, okay, how to utilize and the communication itself. Okay, how to provide an interactive communications. Of course, the robot has to be fit with factual informations. Okay, on it can be facts. Okay, it can be from the nets. Okay, and so on. So these are some of the examples. There's a lot more on how to utilize the social robots. Okay, these are some of the examples. Okay, this one is already difficult to achieve. All right. Next, when we talk about social robots, basically it's just a matter of the capabilities, but the basic concepts we are talking about, the similarities on all these social robots can do. Okay, for this Zembo robot itself, it can be it can utilize or it has the functionality for remote video call. Okay, you cannot just video call. You can also have the remote movement by using the apps. Okay, giving commands, okay? Or you can send your voice over there. Okay, so basically, it's one of the function that if you develop your own robots, it will take some time, okay, for you to achieve these features. Okay, for the streaming, okay, for the communications, for the servers, and so on. So it's not an easy task, but this small robot, this very low cost robot compared to the other robots, can do this. Okay, and it's very stable. And then in terms of the movement, so all robots should achieve this. Okay? The object followings. Okay. And then point-to-point navigations is a basic thing that all robots should do. Okay, should do. And then customized area mapping. So of course, even human, when you go into a new places, you don't even know the environments. So you have to create your own maps. Of course, we are using our brain, but in robots, they have to we have to teach the robot on how to develop their own map. And then when they are moving, it has to be embedded with obstacle avoidance. Okay, you don't want the robot to bump into the walls, okay, or bump into some other objects and so on. Okay, so these are some of the features. Next is what Zembo robot can do. Okay, number 3, on the user interface, the expressions, okay, and then displaying text, image, and videos. Okay, it's a multimedia solutions. Okay, you can combine text and emotions in the same tab. Okay, within the screen of the robots, and you can also provide interactive buttons. Okay, maybe you want to interact, you don't want to use just in case the the speech or voice recognition doesn't work, you have some backup or interactive buttons. And then number 4 is communicates. Okay, how the robot can understand the speech. Okay, nowadays we have a Google Translate. Okay, you can understand, and the same goes to all the robots. Okay, for Android, of course, you can utilize the functionality. Okay, so because of course Siri is very good, but uh, it's not available for Android users and so on. And then the use of voice command and as well as a customized response. Okay, so you want to customize into your own dialogue. Okay, you don't want to use the existing or the Google response. Okay, you want to create your own response in your own language or whatsoever. Okay, so it's one example on how we use this robot for a ceremony. Okay, so just take a look.
All the best.
Okay, so it's been a ceremony for 25 years of our faculty. Okay, so we use the interactions, we use the emotions, okay, as well as using the voice, singing, movement, lighting. Okay, so I think for this kind of small robot, it can do a lot already. Okay, so a lot of AI functionality has been used in this very small robot. All right. Next, okay, so we will talk about all the capabilities of social robots. Now we question how the robot will be able to do such things. Okay, so we talk a little bit on the AI. So now we go a bit deeper. Okay, on what are the functionality. Okay, that is being deployed or being used by social robots. The first one is on image processing. Okay, how from a camera stream, okay, or image stream, you can utilize, you can understand whether it is a car, or is it a truck, or is it a person, or is it a bicycle, okay, or is it traffic lights, and a lot more objects that need to be recognized. Okay, so this is where the AI works. Of course, there should have a data sets. There is ImageNet data sets, millions of data, millions of annotations, okay, that can be utilized for robots. But the question is whether the robot is capable to perform such computations. Okay, it's very high computations. It's quite it requires a good processes, and then it requires a lot of computation. This is just for one functions. Okay, there might be more. Okay, because when we move on the second one is on the natural language processing. You also need to process the voice, the speech, okay, the text, and if you can also, we can also try to implement the sentiment processing, whether you are in a good mood and so on. Okay, and you also have the machine translations, and so these are all. But of course, not all robot can perform all these functions at once. Okay, you have uh, to limit into several functions. Okay, several functions only, unless you have a very good high performance computer to be embedded inside the robot. But of course, the robot will be very big, okay, and not that small like what Zembo can, the size of a Zembo. Okay, so if you want to see some example on, okay, I will show it on. Okay, then number 3 is on simultaneous localization and mapping. So this is one example of how is robots can perform a mapping. Okay, so humans are very great. Okay, we can just memorize all the environments at once. Okay, you just look and you can memorize. But in robot, you have to store all this data. Okay, we call it the cloud data. Okay, point cloud data can be in 2D or can be 3D. So only the places that is being recorded can be retrieved back when we perform the robot movement. Okay, so of course, when the robot start moving, so we have to recognize, keep on recognize and compare to what are the images has been stored. Okay, so you recognize some landmarks here. They have a door. It's a door here. So when the robot move here, then they can try to retrieve, compare the current reading, okay, on of the image compared to the map. Okay, these are the process on localization as well as mapping. It's been done on simultaneously. Okay, we call as normally called as SLAM. Okay, then autonomous navigations. This one is also one area on how to get a point A to point B. Okay, by having an obstacle avoidance. When we talk about obstacle avoidance, there are static avoidance obstacle as well as dynamic obstacles. So, as I said, the environment can be very complex. Okay, but how they did it is by having an algorithms, AI algorithms on path planning, and as well as uh, obstacle avoidance. It can be based on the uh, different sensors. It can be from the image. It can be from the point cloud data. Okay. So these are four of the four main features. There might be more, but I just highlight a few so that you can get some ideas. Okay, for example, for this one, we have some videos, but it's not on social robot. Okay, so let's take a look at the video. So in Instagram, of course, the video is quite short. You can see the full video in my YouTube. But basically, what I'm trying to show here is, in order to move from one point to another, it's not that easy. Okay, you have to perform the trainings. Okay, you have to perform the image processing. Okay, to recognize the lines. Okay, and then the movement. You can detect the sign for parking. Okay, to initiate the task and so on. So when we transform into a social robots, these are the theories of the path planning algorithms that is being deployed. Okay? It might be the simplified algorithms, but the concept is there. Okay, if you have lines, then you follow lines. If you don't have the lines, then you have to create your own line. Then you will follow the trajectory. Okay, so these are the functionality that the social robots should have. Okay, especially for wheel robot. Okay, when you talk about um, uh, bioloid, okay, you have two legs. Okay, robot with legs. It's different issues. Okay, it's very uncertain. All right. Next, we move on to user expectations versus the AI. Okay, so basically, when you ask the stakeholders, what robot do you want? Okay, so I want the robot to have so that is capable to move in huge area. Okay, such as I have a huge house. Okay, or in a big office, not just one floor. It can be two or three floors. Okay, going into the lift. Okay, send some documents there, and then shopping malls. Okay, so the solutions, it has to be the SLAM. Okay, the simultaneous localization and mapping. So this one is one example on how an autonomous vehicle, okay, perform the SLAM. Okay, so they record on point cloud. Okay, they record all the buildings, all the lines, all the even the trees and so on. So same goes to if you perform on inside the building. Okay, but it depends on what are the shapes, important shapes on the building. Okay, if it is only walls, then we can simply use the 2D algorithms. Okay, 2D maps. It doesn't have to be 3D maps. Okay, this is one example on in-class projects focusing on the SLAM. Okay, so if you can see the video here, so they are performing SLAM algorithm. Okay, so these are the students from the class. Okay, performing mapping and then localization. So basically, the process are, you have to start with something to record first. Okay, that's the process of mapping. Okay, you record all the important features, such as the shape of the walls, okay, and so on. Okay, so this one, they are using a LiDAR. Okay, LiDAR is what? Laser range finder. Okay, laser distance and so on. Okay, so some call LiDAR, some call laser range finder, LRF. Okay, it's all the same. They are using an optical sensor, okay, to get the distance. Okay, so it perform in 360 degrees. So from there you can come up with the map, and then you can perform the localization using the AI. All right, so that one is on the mapping. Okay, the mapping. So the bigger the space, then the bigger memory needed. Okay, and the harder localization technique will be deployed. Okay, will require. Number two, expectations number two is robot should recognize and react to object surroundings. It has to understand, okay, understand the whole objects. Okay, for example, the basic one is this one. Okay, so basically this one is one of the our video for competitions, okay, where so besides the movement, okay, you can also perform the face recognition for object tracking, okay, for following person. Okay, so I guess this one, I think just basic functions, but in order to understand more of the objects, then we have to train a new models. Okay, this one is an example of my students performing the detections. Okay, detection on the person, cell phones. Okay, detecting some other objects. Okay, so this one is basically the computer vision's part on recognizing the humans or the objects. Okay, so it depends on there's a lot of things can be done with this. Okay, very customized object detections and so on. All right. So if you see right now they have a Google Lens available in any phones. Okay, where you can recognize, you can take any object, then you can recognize. Okay, it can also be used for social robots. And if you are developers, okay, the most common libraries you are using the OpenCV. All right. Next is on the third expectation. Robot should display understandable information and allow interaction with user. Okay. So the AI solutions, it has to be intelligence and interactive multimedia system to provide the communications. Okay. Of course, when you're using VR and AR, you have to wear the special specs. Okay, and AR, you convert what are the detections. Okay, converting into some visual. So this one is something that is achievable. Whether it's required or not, it depends on the applications. Number four, okay, on the answering the questions. Okay, a robot should answer all questions correctly. Okay, we have Siri, we have Google, we have chatbot. Okay, so in the AI solutions, it has to be a customized chatbot. It has to be supported by voice commands, speech recognitions. Okay, one is an example on a different robots. Okay.
Okay, one moment. I'm Charlie. I'm the demo guy. My job is to show up. Introduce yourself. Okay, one moment. I'm Charlie. I'm the demo guy. My job is to show up. Introduce yourself.
So this one is another example. Just focusing on the natural language processing, okay, and also the emotions of the face. Okay, this one is just a projected images. Okay. All right. So basically, the first part is just to talk on the theoretical side. Okay, what to understand the concepts. Okay, I don't know whether it's in your syllabus or not, but hopefully this information can guide you on learning the overall picture. Okay, so basically, me myself, okay, back in 2019, I think, I met Prof. Patrick and Rebecca in Fancia University, where they bring me to this lab, okay, and showing this kind of robots. Okay, so I don't know how much does it take to program these robots. Okay, but I found it amazing. Okay, but I think we can expand more. Okay, on maybe a different perspective. Okay, so basically, if you try to find from the YouTube, there's a lot of applications like this on the musical part where they can perform a very similar movement and so on. Okay, so that one is maybe a collaborations of robots, okay, of social robots, which is one important parts. But I'm not there yet. Okay, but I just want to show this is one example, one demonstration that makes me feel that okay, I want to bring this home. Okay, from Taiwan, okay, from French universities, and then uh, I bought some. Okay, I bought one robot. Okay, I asked my students. Before that, I asked two of my students to have intern with French universities. Okay, so going to the IoT labs with Dr. Rebecca. So what they did is we don't explore the block programming. Okay? They explore the Android SDK. Okay, so the task is on developing a simple app. Okay, on Frencha University, Frencha Night Market, as well as the Department of IECS FCU apps. So this videos shows the outcome of this. After when they went back, they bring back the robot to me.
Tell me the night market history. Taiwan price. Yes.
So it's a customized app. Okay, it might not be complete, but enough to say that the projects I can say successful in from zero exploration until in 3 months they can produce this kind of apps. Okay, but there's more to explore actually. Okay, so basically these two of my best students on robotics I sent there. Okay, with the help of Dr. Rebecca giving some fundings. So basically, another guy is working on the IECS lab app. I will show it later. But uh, how we did it at first? Okay, if you are not familiar with the Zembo or you are new, okay, first you have to learn on the overall process, okay, of the app development in Zembo. Okay, on the dialog developments, okay, on the environment DDE editors, okay, and then the app builder, and then you have to specify the app domains, okay, on to get the relevant dialogues, and then you develop the UI UX, okay, for user interactions. So here they have the DDE editor here, okay, on the dialog system. You customize it to your own specific domain, and then you can use the camera app if you want, and using the motion, vision, and utility to give additional features. And at the end, you want to communicate with the user, okay, on voice command, and then the app will display in the tablet. Okay, so if you use on voice recognition, then it can be voice recognitions. But if you focus on the the button, then it will become button. Okay, so I have to move a little bit faster. It's 1:15 already.
Who's
These
far?
are the
Who's how?
example on IECS apps on another guy, okay, on developing the IECS apps, okay. So exporting all the database as well as providing the interface, the backgrounds, okay. And the purpose is for the first project is very simple, just to create a simple UI and to get the phrases. Okay, when you talk lecturers, they will show the list of lecturers. When you talk give command laboratories, they will show all laboratories and so on. These are all the phrases that you can say to activate the functions. And then in the night market, the purpose to search for specific shops, okay, and the processes, you have to specify all the database, okay, and what are the keywords, and also you have the error handler, okay. If they haven't found any keywords, what should the robot returns the feedbacks. Okay, so these are some of the keywords, okay, on the dish name, okay, on the cook method, and then as well as all the images. Okay, they have to store all the images. And then okay, the latest one is we perform ARC stand for Artificial Intelligence Robot Challenge on Zembo competitions. So this time we focus on the COVID-19, where they stay at home, so they don't have access to the robot. So they access using the online simulators, okay, only using the Blockly, okay, the app builder, but they have to program the DDE, okay, to produce the outcomes. Okay, so basically, if you want to see the videos, is in the YouTube. Okay, so so maybe a little bit on the outcomes. Okay, so so these are the program. Okay, and how to reply. Okay, what are the questions asked by the Zembo? Okay, what are the sequence of dialogue that you want to focus on? Okay, so for this one, about 10 participants. Okay, and then we choose the best 3, and this is the winner of this project. Okay, so it might be simple, but because students come and go, so we have to keep on the transfer of knowledge between the one batch to another. So this is how we create the momentum for them to keep on developing something. Okay, it depends on the situations. All right, so you can see if you want to see more, you can see the video in my YouTube's. In my YouTube, there is some. I put some videos on the apps. Okay, the apps that have been developed inside the in our labs during classes, some of the projects, and so on. All right, maybe a little bit more. I want to get some questions from you. All right, and then this one is number 3. The sequence is this one is the competitions that has been performed. This one is the where Patrick sent 2 of the students to National Science Center of Malaysia. Okay, so you can see all the images been uploaded in facebook.com. Arvis ARC. Arvis is my lab, autonomous robot and vision system lab. And these are the winners, come from I think 7 universities, okay, including the Frencha. Okay, they are going from Frencha. Okay, because supposed to be the Ontario Tech. But this one is one good competitions. But of course, from here we found a lot of issues. Okay, on the communications, on the sound, limitation of Zembo that occur during the competitions. But we got some outcomes. We got some networks interested in these robots. But however, we cannot simply purchase the robot, to expand the ownership, so they can build it on their own. So it's quite hard for us to continue on the next year, on the following year to continue for the competitions. So yeah, it's quite challenging, but we are still waiting for this robot to come to Malaysia. I don't know whether it will be coming or not. But so far, we focus on the online and creating modules for specific target users. All right. So that one, number 6. So it's our sequence now. So number 4, this one is when we invite Paul Patrick and Dr. Rebecca come to UKM, to share some of the knowledge on focusing on the privacies, as well as the sharing session on development of Zembo in FCU. These are the my team, my researchers in UKM. So it's an interesting topics, it's from different perspective on the security part, on the privacy protections, where we didn't cover on that. We are focusing on the technology itself, on the algorithms, but it's good that we hear that somebody is working on it, and maybe some new area that we can focus on. Besides that, Zembo class project, these are the apps that have been built during the class. You can see from my YouTube if you want. Okay, last one. What are we going to do next? Okay, we try to integrate with the existing system with some web system. Okay, still waiting for some students to do it. Okay, and might be we need to have an external vision system, because this robot have some limitations on the vision, where we cannot do much. And then to include in monitoring systems, maybe. And then Zembo to Zembo communications right now is quite difficult, because I think the SDK is not open for this. We try to discover this, but they have to pay for some subscription and so on. And maybe the use of Zembo in educations, for fourth revolutions, fourth industrial revolutions, on utilizing the functional capabilities, especially on the interactions, and on the visions and the speech recognitions, that has been the capability of the best function, the best features so far for Zembo. Okay, so still we are in early phase of this part. Okay.
Interactions, Dr. Hadi, right? Thank you so much.
Okay. All right.
Right. Anyone? Any questions? Anyone? No. Before we let Dr. Hadi to go to bed. Now it's late over there in Malaysia.
Yeah. Almost 2 a.m. already.
Almost 2 a.m. Yeah. Anyone? No. Okay. If no, I should know. Okay. So, Dr. Hadi, thank you so much for coming and giving us a very interesting presentation, and you helped me a lot. You show all the Zembo features, functions to them. I don't have to repeat those things to the students. And I think your slide are very good, very, very attractive. And I think you really motivate and I think inspire our students for the course project. Okay, thank you so much.